All right, today we're going to worry about starting our circles unit, and we're going to do area and circumference of circles, and also talk about what major arcs and minor arcs are in a circle and how to find their measurement. So just to start out with, I've already written down the definition of a circle, and that's that all the points that are equidistant from a given point in the plane. And the rest of these words, I'm going to kind of either refer to that definition or try to draw on this diagram over here. So in my circle definition, all points equidistant from a given point in a plane, the center of the circle is actually that given point that they're talking about. So the given point, all that is the center of the circle. So this won't be perfect, but I'm just going to kind of eyeball that on the diagram over here. Now, the actual equidistant means the same distance or distance, and that is actually the radius of the circle. So each one of the points, if I draw a line here, if I go from the center to any point on the circle, that distance is equal for every single point on the circle, and that distance is called the radius. Now, special parts of a circle, diameter is actually gonna go completely through the center, touches 2 points on the circle, and goes through the center. So that's going to be the diameter. It's actually 2 times the radius, because you'd have a radius and another radius that make up the diameter, so that goes all the way across. Semicircle is half a circle, and that's also equal to 180 degrees. If you're talking about degrees, all the way around a circle's 360, halfway across, which also the diameter represents a straight line, so hopefully we're familiar with that as 180 degrees. Circumference is a special word for the perimeter of a circle, and I'm just going to jot down the formula, 2 pi times the radius, or another formula you can also use, pi times the diameter. So 2 times the radius is equal to the diameter. That's why you can have 2 interchangeable formulas there. And area of a circle is the amount of space enclosed by the circumference or by the perimeter. So it's the space inside there, and that's going to be the area. That's pi r squared. Now we're going to do a couple of things when we talk about finding area and circumference, and first thing we're going to work with is talking about how to find things in terms of pi. So in this diagram right here, I have a radius of 12, so I'm going to go ahead and say circumference 2 pi times my radius. If you want to leave your answer in terms of pi, that means we need to see pi in the answer, so I can plug in my radius being 12. If I want to leave that in terms of pi, what you're going to do is take 2 times 12, which is 24, and just write a pi next to that. Now this would just be feet. If we're talking about a distance of any kind, it's not squared or anything like that, so the label would just be feet. Now here, the diameter is being given to you as 4 meters, so that means the radius is 2. If I want to find the circumference in terms of pi, 2 pi times my radius, so 2 pi times a radius of 2 would give me 4 pi, and this would be meters. Now, if we're going to find area in terms of pi, area, pi times your radius squared, so you do have to identify the radius. They're giving you the diameter to be 20, so this would be pi times my radius squared, or 100 pi, and then because we're talking about area here, the label would be yards squared, or square yards. And actually, this circle and this circle end up having the exact same area in terms of a number, not in terms of units though. The radius here is 10, so it's exactly the same thing we just did. However, 100 pi, this one would be centimeters squared, because we have some different units there. Oh, that's not a negative. Alright, now we're going to give you area or circumference here and ask you to find either the diameter or the radius of the circle. So this is kind of working backwards. So area is pi times the radius squared. So I know the area is 4 pi, and so I'm going to set that equal to the area formula. If you were to divide both sides by pi, that actually cancels out. So 4 is the radius squared. We would need to take a square root there, so the radius would be 2. So let's get rid of the squared by taking a square root. Circumference here, 2 pi times the radius. I know the circumference is 162 pi. And same concept, if I divide both sides by pi, it actually cancels out on both sides. So 162 is twice the radius. If you, I didn't leave enough room here, divide both sides by 2, 81 would be the radius. And I just realized on both of these I was supposed to find the diameter. So let me my apologies, back here, this one the diameter is twice the radius. So if the radius is 2, diameter is 4. Over here, if the radius is 81, then the diameter, we would multiply that by 2, would be 162. This one is in inches, this one is in yards. Now these two ask you to find the radius. So area is 49 pi. Just going to set that equal to the area formula. The pi's cancel out. 49 is the radius squared, so the radius is 7. I'm going to give the circumference in this part, and so I'm going to set that equal to the circumference formula, 2 pi times the radius. The pi's cancel, so 30 is twice the radius, so my radius there is going to be 15. Whoops, this one is yards, and this one is also yards. Alright, now the rest of this I'm also going to use this blank circle here to illustrate some of the definitions we have going on. So a central angle is an angle whose vertex is the center of the circle. So I'm going to come over here and just kind of eyeball, oh sorry guys, the center of the circle. So an angle whose vertex is the center of the circle. So I'll just draw an angle here. And I know that's not perfect, but this angle would be what we would call a central angle. Now, what we call an arc, and there's different types here that we're going to talk about, is just part of the circle. And so I'll just draw a little with my highlighter here. This kind of cut off by your central angle would be called an arc, and that's actually an example of what I'm going to talk about first, which is a minor arc. So a minor arc is any arc whose measure is bigger than 0 but less than 180. So I don't know about how many degrees this is. I don't know, let's say this is about 48 degrees or so, and just making that up, I didn't measure it. The arc measure would be the same. So the arc measure is going to match up with the central angle. We'll talk about that more in a second. Now, what we would call a major arc is greater than 180, so that means it's more than half of a circle and less than all the way around the circle, which would be a complete 360. So 360 degrees is a full circle. So what we would call a major arc is going to go more than half a circle, but not a full circle. So half a circle is called a semicircle, and then all the way around would be a full circle. This that I'm highlighting right now would be an example of what we would call a major arc. Now, I could also figure out the measure of that really quickly by, if I know this much of it's 48, the rest of that angle we know all the way around in a circle. I'll just kind of lay my calculator here so you guys can see it. But if I did 360 minus 48, you're going to get 312. So this part, this angle out here would be 312. That would also be a central angle. I know that's kind of weird because it's going that direction, but that arc measure then, that major arc would be 312. This would be a minor arc, and this would be 48. So I'm going to slide down here in the drawing, and I'm just going to write down as many minor arcs as I can. So one minor arc would be less than 180 degrees, so AD. And when you see an arc, they're going to have kind of like a little arch over the top of them to identify that we're talking about an arc. AC would be another example, also less than 180, but not in existence, so there it is. We have CE. Now, these are like line segments. When you're talking about a minor arc, you can flip the letters around. So EC and CE would describe the same arc. I also have E to D, that's less than 180. And at that point, we've labeled all the minor arcs. Now, semicircle is exactly half a circle, so you'd want to look for a diameter. An example there, A to E, that's exactly half. I would have D to C, that's exactly half. Those are both considered semicircles. Now, a major arc that contains the point E. When you have a major arc, you're going to have 3 letters in the description. Minor arc is 2 letters in the description. That's another way that you're going to know which type you're talking about. So, containing the point E. So I'm going to look right here, and I have to go at least farther than halfway around the circle. So if I kind of think about it this way, if I go, A would be a semicircle, so I don't want to use A, I would need to go farther than that. So if I would call it E, and you could actually use either C or A here, it doesn't matter. Let's say I called it ECD. That would describe the arc going E to C to D. The second letter tells you the direction around the circle to go. So that would be an example of a major arc because I'm more than halfway across the circle. Another example, I'm just supposed to include the point E, so another example there, I could go ADC, for example. ADC would go to here. Again, the second letter tells you the direction to go around the circle. These don't have a specific clockwise or counterclockwise, it's just in the direction of the second letter. So it has to be here, AD, and then I end up at C, and that's an example. Now just giving you guys a couple other examples here. Major arc that would include the point A. So somewhere, maybe I could go, if I started at C, and I went to A, and I kept going around and I ended all the way back up at E. That would be an example of a major arc. All the way, it would be everything except that little minor arc right there. That would be an example. And we think of a different example that contains the point A. If we did, let's see, if I did D to A, I'd have to go past C because that would be a semicircle, so I could do D to A, and I'd have to end up at E. So you can go clockwise or counterclockwise, that doesn't matter. The first letter is the letter you start with, and in a major arc, the second letter is telling you which direction to go around the circle. So it just has to be more than 180. You cannot go more than fully around the circle to include a major arc. Okay, and then lastly, I mentioned this at the top, the measure of an arc in a circle actually is the same as the central angle. Now there's different ways to find arc measures, but we're going to start out here, and it matches the central angle measure. So if I go completely around 360 degrees, that's a full circle. So if I'm coming from the center of the circle, that's true, and if I'm coming around the outside, that's true. So we're going to identify some different either angle measures for central angles or arc measures in this diagram here. So I'm just going to label a couple of things I already automatically know before I start answering these questions. This angle is 32, so the arc will be the same. Here the arc is 58, so the angle will be exactly the same, the central angle COD there. Now, use any diameters that you can see in the diagram. So from C to A, that is a diameter. It touches 2 points on the circle and it goes through the center. So I know that's 180. So if I subtract 58 from that, this angle is 122 degrees. And this arc, D to A, would also be the same. And same argument, but I'm going to come on this side of the diameter there. If I do 180 minus 32, this BOA is 148 degrees, that angle, and the arc from B to A would match that central angle. So just going to go from there and see what we can fill in. Arc BC, we got that labeled already, 32 degrees. AOD, so AOD, that central angle, we've got that labeled at 122. BOA, that's the 148. BD, okay, now this one, I'm just going to add the two arcs together. So BC is 32 and CD is 58, so B to D would just be 32 plus 58, which is going to give us, exactly 90. Okay, now ABC, so that means start with A. Now, you don't go around this way. All right, if you're getting to B, you want to go around so it's less than 180. So that's how I know the direction to go. So if I went like A, B, and then the last letter is C, that would go more than once around the circle so that I know I've gone the wrong direction. So from A to B to C, that actually is a semicircle, 180. All right, now DAB, so don't go more than once around the circle, otherwise you're going the wrong direction. So we're going to go this way, D to A to B. So D to A is 122. So I'm going from here, and then A to B is 148, so it's 122 plus 148, and that's going to be 270 degrees for that arc measure. CAB, now again, if I go this way, I'd have to keep going more